Hey everybody, it's me, and today I'll be giving you a tutorial on how to use my neural network template slash base to create your own neural networks in Java. Now, let's begin by explaining what a neural network is. A neural network is basically an algorithm that teaches itself to output a specific set of information in response to a specific set of inputs. For example, the YouTube algorithm is one of these. It takes in information which consists of, for example, the videos that you liked, the videos that you watch, and then as a result, it recommends you videos that it thinks you would watch because of your based off of your past watch it, based off of your past watch history. Now, this neural network base is more like a very simplified it's a very simplified version of a neural network, which just takes in information and slowly trains itself based off of a bunch of information that you give it, and learns based off of that. So yeah, this it's on GitHub. I put it on GitHub, and the link should be in the description. Should be. Hopefully I don't forget. Um, where you can download it. It also has the GitHub also has like a read.md that basically explains it, but but it'll I'll basically be doing that in this video. I mean, like that's kind of the point. That's yeah, I'm stupid. Uh, anyway, let's get into it. So, oh, actually no, fuck. First, let's go into this. When you download it from here, you'll get like two things. License doesn't matter. Read.md, basically this, which you can read in the GitHub. But these two things are what matter. The neural network base, this folder is what consists of like the actual code. This is basically the same exact thing except with an example that I put into it, which I'll be going through later. Alright, so yeah. I coded this thing in BlueJ, so as a result, it has a BlueJ package file, but it should if you're using a different IDE like Eclipse or whatever, you should just be able to import the Java or class files. But if there could be a chance that there's a problem because I'm using BlueJ, but well, whatever. All right. So you run the program by just running the void main from the draw class. So once you do that, it'll output first it'll go through it'll print out a bunch of like training sessions, and then afterwards it'll give you like a window, a full screen window that shows you like what's going on, like the nodes, the weights, and the outputs and whatever. So let's go over this for a second. So a neural network, it basically consists of a bunch of layers of nodes and weights. So these smaller circles that these big let's go through. Let's do this one by one. All right, so these big circles are all nodes. They hold information. That's basically it. And then these smaller circles are the weights. These are the modifiers, which I guess modify how the information from one node is transferred to another. So you can see through the lines and connecting that this node, for example, 1, 0, is taking in data from both this bias node and this node, as well as this node, and it's being modified by these weights, these three weights. Each of these nodes are being modified by these three weights to get to 1, 0. And then it just keeps going on and on. So these will be your inputs, and the like the leftmost nodes will be your input layer, while the outer like the rightmost nodes will be your outer output layer. So on top, you also have like sorry your inputs, your actual outputs, and your expected outputs. So look, for example, in this case, you have two inputs, 0.15 and 0.35, and node 0 and node 1 respectively, and you're expecting the testing information is expecting that you'll get an output of 0.0 in the output node 0, and and an output of 1.0 in the output node in the 1 output node, right? But these are your actual outputs over here. They also appear like, oh yeah, the values of the weights and the nodes all appear inside of them as well. So to make it simple, these are expected inputs. These are actual. These are inputs. These are actual outputs, and these are expected outputs. You can see like through this information, you can see like how accurate your neural network is getting. So, if you don't care about this is like the main place that you modify this neural network through the base. It's just in this function. You put in everything here. That's if you don't want to go into like my actual code or like modify any of that, or like maybe like add new features to the neural network. For example, displaying information in a different manner. So to you, these 4 classes, I guess other than running the void main from draw, shouldn't matter, unless you're planning to change the program itself. If you're just planning to create a basic neural network off of it, the driver class and the set neural network settings function inside are all that should matter to you. So I think one way of just explaining this well would just be going back into the read.md that I put on my GitHub. So yeah, over here, how to modify, how to modify the program to fit your needs. You run the program at blah blah blah. Okay, so these are the main like variables or whatever that you'll be modifying in order to like customize the neural network. In order to create your neural network through this through the usage of this template. So let's go through each of them individually. Layer stats. This is probably the blueprint for your neural network. So layer stats will be layer stats is very important to control because there's a lot of stuff that goes into this one array. All right. So for example, in the neural network that I showed you, which is like the one that this base comes preset with, it has a 2, 2, 2, 1. So let me explain to you. The last digit of this array is a setting. It's whether to enable or disable bias nodes. If I run this again, these are the bias nodes. You see, they're denoted by like a -1 in their address. All right. So this 0 bias node is between 0 and 1. So it's 0, -1, and this bias node is 1, -1, which is between 1 and 2. So these bias nodes are automatically set to to have a value of 1 in order to just like help with calculations. So the last, like no matter what you put in this array, the last digit will always be the setting to enable or disable bias nodes. I just did this because I thought it would be simpler for me to code as well as like to help save space. All right, so fuck. All right, so layer stats. So the other everything other than the last digit of this array determines like what your neural network is composed of. So because you have 3 digits, 2, 2, and 2, the neural network will have 3 layers. The neural network will always have one input and 1 output layer. So the input layer would be the first digit that you put into this array, and the output layer will be the last digit before the layers before the bias nodes enable of the array. So each layer will have like the amount of like the number of nodes which denoted in each like thing. So because of this, all right, let's change it up for a second. So if I put this, this will create a neural network with one input All right, one node in the input layer, 4 nodes in the first outer layer, 3 nodes in the second outer layer. I mean 4 nodes in the first hidden layer, 3 nodes in the second hidden layer, and 2 nodes in the outer layer. So you can make as many like layers as you want, but there will always only be one input layer and one output layer, and the rest in between will be hidden layers. All right. I think that's it. Yeah, that should be it. Learning rate basically, and changes like the modifier by which like the neural network will learn. I'm explaining it really shittily, but like the magnitude of which the neural network will change like after each test. So after the neural network like does its calculations, it gets the output, it gets the expected output, and measures them against each other to change the weights. This is the learning rate is the modifier by which like the weights will change. So if you put it at 0.5, which I left it at, it'll change like just fine. Like if you put it at 1, it'll change a lot every round, and if you put it at like 0.1, it won't change much. Like yeah, that's basically it. All right. So step based. This gradient checking is something I might implement. It's either implemented right now or I may implement it later. I forgot. I wrote this like a few months ago. Yeah, sorry. Step-based. So step-based basically means that like you saw at the beginning when let me just run it through again. You saw at the beginning like how like oh fuck what the oh yeah oh shit okay never mind. This is because this error is because I messed with this without changing the testing array, which I'll get into later. But basically, step-based means that like after the neural network does its like run through a bunch of like preliminary tests, it'll continue to like update and teach itself as like the new window pops up. Alright, wait, let me just re-edit the code in the back like what it was before, so we won't get an error this time. 2221. Okay, so that'll make explanation a bit easier. So like you see after all of that, so these were like the preliminary tests, but step-based should means that like the neural network will continue to teach itself and update like the numbers after these preliminary tests. So the reason why it's not changing itself is because like this data kind of sucks. This is just like one example. So as a result, that like after a few tests, the neural network has already reached like the max, like what it considers to be like the best state and most accurate state. I'll show. I'll show you this in an example later. So number of tests. This is basically the thing I was saying before. The number of preliminary tests that runs before like the window pops up. So for example, again, like 1,000 the 1,000 tests have just been run here, but and then this pops up. Oh yeah, you'll also see like the amount of tests that have been like ran on the top right over here. Frame speed. This is the amount of milliseconds between like each update. If step-based is enabled, set to true, frame speed will determine like how fast like the amount of milliseconds between each test and window update. And this testing array is probably like the other most important thing around other than layer stats. This is basically the information that you'll use to train your neural network. Alright, so let's make this look a little better. Alright, so the testing array is a 2D array which holds like sets of inputs and outputs. You see how like over here there are two there are 2 nodes in the input layer shown by here and 2 nodes in the output layer shown by here. So as a result, each test which consists of 2 arrays of doubles must like have like each respective amount of like information. For example, this is the only like fuck. I mean, okay. This is the only. What am I doing? This is the only like point like set of information that the current neural network is using, which is why it's not changing after the 1,000 tests. So okay, so as you can see before, this puts in this has an input of 0.15 for the first node of the input layer, and 0.35 for the second node of the input layer, which equals to and these are the expected outputs of that test. These are the inputs. These are the this array is the outputs. So so it if the neural network takes in an input of 0.15 for the first input node and a 0.35 for the second input node, it expects this output, an output of 0 for the first output node, and an output of 1 for the second output node. So yeah, that's basically everything, and how like the neural network trains itself, and how to create your own. Along with this base, I've also packaged in an example. An example, which is over here. So let's open that up, and we can go through that to see how that works. Okay. So first, let's look into the driver code, and I'll explain everything. All right. So the rules of this example are basically that it has one input node and two output nodes. The rules of this neural network is that basically if it randomizes, it goes through the testing array and just picks out random like sets of information to test the neural network against. So an input of 0 for the input node will result in an input of 0 for both output nodes. An input of 0.1 for the input node will result in an output of 0 for the first output node, and an output of 1 for the second output node, and so on. You see. All right. So the layer stats. Bias nodes are enabled in order to make things more accurate. The neural network has two hidden layers with three nodes each. One input node, which takes in like this information over here, and two output nodes, as you can see. So the learning rate is 0.5. Gradient checking doesn't really matter. So right here it runs. It's step based, so it'll continue to update every 100 milliseconds after these preliminary tests are run. So it'll run 50,000 tests beforehand, and you can see. So if the testing array has more than like two sets of like one set of information, so I consider like two arrays of doubles to be one set of information. It'll randomly for each run. It'll randomly pick out like one set of information and just like go through it to train the neural network. So let's do it. So 50,000 tests will take like a bit longer, but you can see like the neural network learning over time, because it went from like it went from more like random outputs to more like accurate outputs that relate to like 0 and 1. Actually, wait, I should slow it down. Okay. So this will make it that'll update every 1 second instead of a tenth of a second. So it does the 50,000 preliminary tests, and then yes, now it does this. Oh yeah, I've made it so that the weights and the nodes sort of change a little based off of like their current value. So you can see that the neural network has learned a lot over the 50,000 tests, because its outputs have been getting really close to the expected outputs over here. So for example, you'll see like so 0.9 is very close to 1, and 0.14 is closer to 0, is pretty close to 0. Now so that's basically it. So you can also see like how like ineffective how inaccurate it'll be if it only gets like a 1,000 tests instead of like the 50,000 that you see. Yeah, see, like it's more as a result of it not like learning as much. The outputs are more like around point 0.5 or point 0.4, which are far away from like the expected outputs compared to like point 0.9 and point 0.1. So yeah, that's basically it. Thanks for watching this video. Yeah, stop recording.